Hey guys, today we're going to be talking about arithmetic and geometric sequences. So underneath the do now, look at that first sequence given, 3, 7, 11, 15, 19. See if you can find the pattern in words for the sequence. You can pause the video at any time, remember that, and then pick it back up. You can always rewind it if you need help. So if you look, how did I get from 3 to 7? How did I get from 7 to 11? You should be able to see that I am adding 4. Part B, I already graphed it for you. If you look at the graph, and I wrote as ordered pairs, so the terms are on the bottom, so term 1, term 2, term 3, term 4, okay, your term number rather, and your terms that go with it are on the side. So the first term was 3, the second term was 7, 11, and then 15. What do you notice about the graph? So if you look, it kind of looks like it is linear. This type of sequence is called an arithmetic sequence. So you're going to fill in these spaces. Again, if I move too fast for you, you can stop it, pause it, rewind it. So an arithmetic sequence uses the operations of adding and subtracting. In the last example, we added 4. They have what we call a common difference. So in the last example, your common difference was 4. Arithmetic sequences are modeled by linear functions, as we just saw, and arithmetic sequences have a constant rate of change. Underneath that, there is a formula to find the explicit formula for any arithmetic sequence. This is on your reference sheet. You don't have to memorize it. You do have to understand it. Okay, A sub n stands for the nth term. And I'll explain more what that means. A sub 1 is the first term. N is the term number. And the D is your common difference. Now, when we say the nth term, if I said to you the 6th term, the 7th term, the 100th term, we use the nth term to display that. And if I wanted to write the 6th term, I would do A and a subscript of 6. That means the 6th term. So if you turn the page, let's practice a couple of those. So recall, the terms of a sequence can be listed with subscripts, A sub 1, A sub 2, etc., where n represents the term number. So given our sequence 8, 5, 2, -1, -4, list each term with the appropriate subscript and state the common difference. So A sub 1, my first term is 8. A sub 2 is 5. Pause the video and you're going to do A sub 3, A sub 4, and A sub 5 and tell me what the common difference is. Once you figure it out, you can unpause it and we will go through the answers. So A sub 3 is 2, A sub 4 is -1, A sub 5 is -4. Your common difference, what am I adding or subtracting to get to each term? I am subtracting 3. Right, so -3. Some practice questions. Find the 10th term of the sequence. So first I need to look at it. Right now, all we know is arithmetic. In a little while, though, we're going to be doing geometric. So look at it. Look past the first 2 or 3 terms. Always make sure all the terms fit. When I'm looking, I see 3, 5, 7, 9. I say to myself, okay, I add 2 here. Do I add 2 again and again? Yes. If you're adding or subtracting, that means it's arithmetic. So that means I'm going to use my formula that we just went through. And just like with word problems, I'm going to write on the side my variables here. Find the 10th term. So that's the term number. N A sub 10. That's my N, 10. The first term, well, look at the pattern. 3 is A sub 1. That stands for the first term. And if I look, it's 3. And we said our common difference is what we're getting to the next. I'm adding 2. Once you have that, now I can just fill in. And I plug in A sub 10 equals 3 plus 10 minus 1 times 2. And I'm going to solve it out. That's going to give me my 10th term. And you can do it step by step. You can plug it into the calculator, which is what I suggest at one time from here, from the very first step. I would just plug it all in. Okay, so A sub 10 is 21. If all else fails, you can keep adding 2 till you get to the 10th term. The problem is on your regions, they might ask you for the 75th term, where then it might take you a little bit longer if you use the calculator and add 2 every time. Practice question number 2. What is the formula for the nth term of the sequence? So again, I'm going to look from 10 to 12. I add 2, add 2, add 2. So it must be arithmetic, so it's linear. So if I look, I can cross out 3 and 4. Those are not linear. Those are not being added. My first term is 10. My common difference is 2. Now I'm looking for the nth terms. This is any sequence. They didn't ask me a specific one. They just want the general formula. Remember our general formula? So A sub n, my first term was 10. My common difference is 2. I'm going to distribute that 2. So I get 2n minus 2. Because if I look at your choices, I don't see this one here, right? So I got to try and see, okay, maybe it's, I got to clean it up a little bit. 10 minus 2 is 8. 8 plus 2n, does that look right? Looks good, that's there. So choice 1. Number 3. Find the common difference of an arithmetic sequence with first term 4 and 11th term is 64. So my first term is 4. My 11th term is 64, so I can also say my n is 11 then, because we're looking for the 11th term. We're looking for the common difference, but our n is 11, right? And again, so find the common difference. I'd put a question mark there. Don't mind my smartboard. You guys know it's crazy. Okay, so a sub n, our 11th term, a sub 1 is 4. We're looking for the common difference. Remember that our a sub 11 is 64. That's the 11th term. That's what they told us. So I can replace a sub 11. It equals 64. So 11 minus 1 gives me 10. And then I'm just solving for d. I'm going to subtract 4. And I'm going to divide out 10. So d equals 6. Pause the video. You're going to try number 4 and then pick it back up so you can check your answer. So our common difference, they told us it was an arithmetic sequence. If they tell you it's arithmetic, they make that easier. They're saying, okay, you right away, I know I'm adding or subtracting. So from 16 to 10, I subtracted 6, subtracted 6, subtracted 6. There's my common difference. So those are arithmetic sequences. Now let's look at another sequence. 3, 6, 12, 24. Describe the pattern in words. So what's happening? How do I get from 3 to 6? How do I get from 6 to 12? I'm multiplying by 2. I'm multiplying by 2. Some of you might have said, oh, but you add 3. That's true, you add 3 here, but do you add 3 again? No, now you're adding 6. And for arithmetic sequence, it's always a common difference. You're adding the same number every time, right? So that means that that's not arithmetic. I'm multiplying by 2 here. So if I look, if I graph this, which is graphed on your paper for you, this is the term number. So the first term, the second term, the third term, and the fourth term. And this is the actual term. Right? And our terms here were 3, 6, 12, 24. What do you notice about the graph here? Well, if you look at it, is that a straight line? If you try and connect those points, it's not going to be straight. It's going to have somewhat of a curve. So to me, I don't know about you, but this looks exponential. This type of sequence we call a geometric sequence. So please fill in the blanks. Your geometric sequences use the operations of multiplying and dividing. Geometric sequences have a common ratio. Okay, it's symbolized by the lowercase letter r. Geometric sequences are modeled by exponential functions. And geometric sequences have a percent rate of change. So if you need to, pause the video and fill those in. The explicit formula for a geometric sequence can be used to find missing information. Again, this is on your reference sheet. You need to know how to apply it and understand what each thing means. So similar to the other one, the a sub n is the nth term. A sub 1 is going to stand for our first term. Now instead of a d, we have an r. That's our common ratio. And the n is going to be your term number. So I don't have to memorize this formula. I do have to know what these mean, though. We turn the page. Let's go to some practice problems. So number 1. What is the 15th term of the sequence? Again, they didn't tell us it's arithmetic. They didn't tell us it's geometric. You want to try and figure that out. So when I look at it, I'm going to look and see from 5 to negative 10. I can see what I added to get there or subtracted. Or I can say, all right, let me say 5 times, right, negative 2. Oh, if I multiply by negative 2. Okay, so this must be geometric, so I'm going to use my geometric formula. Again, I like to always write out my variables. What is the 15th term? So my n is 15. That means that this is a sub 15. The first term, they gave it to us in the sequence. It's 5. I had to find the common ratio. I figured out we were multiplying by negative 2. And now you're just going to plug it in. Right into the calculator. Don't make your life difficult. Plug it in at one time. Do not try and do PEMDAS and do it by yourself. Some of you are going to multiply the wrong thing. Just plug it right in there so we don't make any errors. And when you plug it in, verify this should be your answer. So we should get choice 3. Make sure you plug in right now to make sure you're getting this. Otherwise, you might have missed the minus sign. You might have missed the negative, positive. Okay, number 2. What is the formula for the nth term of the sequence, 54, 18, 6? So right away, I'm going to look. Is it arithmetic? Is it geometric? Okay, well, if I look at my choices, I can see it's geometric because right away, I only have multiplying, right? Exponential equations, they look like. Your initial term, that's what goes first. My a sub 1, they have a correlation, right? So 54. So I know right away, I'm getting rid of this. Your formula, a sub 1 r to the n minus 1. The r's are all the same. I don't even have to figure that out. It's 1/3. All I need to know is the formula. Look at my reference sheet. It says n minus 1, so choice 4 is correct. Number 3. Find the common ratio of a geometric sequence whose first term is 27 and fourth term is 64, and they want me to find my common ratio. Okay? So if I plug it in, I'm going to say my fourth term is 64. So I can also say then n equals 4. So if I plug in, here's my formula. I always like to rewrite the whole thing out, that way I know exactly what I'm placing. This is a sub n, which is a sub 4, or 64. A sub 1, my first term is 27. I'm looking for r. My n there is 4. And then I can solve this out. I can divide out the 27. I can do 4 minus 1. How do we get rid of something cubed? You can raise it to the 1/3 or take the cube root. That's the same concept. The cube root, those are both perfect cubes. 4 over 3. And again, let's say you were confused about that. You have a calculator. They're giving you the common ratio. One of those are the answer. So you're going to take the first term and keep multiplying by 3 over 4 until you get 64. That didn't work? Try the next one. I'm going to take 27. I'm going to multiply by 64 over 81. That didn't work? Try the next one. And think about it here. This number is getting bigger. It went from 27 to 64. So your number you should be multiplying should be greater than 1. These are both less than 1. Always try and use techniques to cross out choices. Number 4, pause the video, try it on your own, and then check your answer. So what is the common ratio of the geometric sequence? If I look, they're telling you it's geometric, so right away I can say, okay, what am I multiplying by? If I look here, I can say, oh, goes to 4, then -8, so I'm multiplying by -2 is correct. Again, I'd like you to pause the video and I'd like you to try this. This was a regions problem given. See if you can try it, and then I'm going to go through it with you. So Elena has decided to run the Buffalo Half Marathon in May. She researched training plans on the internet and is looking at 2 possible plans. Jillian's 12-week plan and Josh's 14-week plan. The number of miles run per week for each plan is plotted. Which one of the plans follows an arithmetic pattern? Explain how you arrived at your answer. Well, arithmetic goes with linear. Which line looks linear? The dots look linear, which is Jillian. So I'm going to write down Jillian's, because if connected, it would form a line. And if you look, it has a common difference of 1, right? Every term is going up by 1. Part B. Jillian's plan has an alternative if Elena wanted to train instead for a full 26-mile marathon. Week 1 would start at 13. So week 1 would start at 13. That tells me that. Our A1 is 13. And follow the same pattern. What does that mean, the same pattern? The same pattern, well, our pattern was just add 1. So that's the same thing. But it would continue for 14 weeks. Write an explicit formula so we know it's arithmetic. We're looking for an explicit formula, so that means for any term. A sub 1 is 13. This means for any term, our pattern was 1. And it tells you in simplest form, so I want to clean this up. I'm going to distribute that 1. I get n minus 1. If I combine like terms, my explicit formula would be a sub n is 12 plus n. If you turn the page, we're going to skip that top part 1 and 2, but you're going to try the mixed practice on your own. We'll go over it Monday in class. And you're also going to be given now a homework sheet. Go up to your teacher that's there, ask them for the homework sheet, show them that you finished, you filled everything in, and you're going to work on that homework sheet. It's due on Monday. Hope you enjoyed your sequences.